So I just want to start by saying that technologies have always been shaping the way we do things and our society. So if we look back, for instance, at the time when we started developing farming more intensely, we started coming together as community, society. We started creating different norms so that we can work together. So we started seeing changes very early on through the use of technology. If you look more recently, for instance, at the time of the Industrial Revolution, we have the steam engine train. It may now look like something that we are, traveling, we're all used to it, but at the time, can you imagine what difference this made to people's lives? Suddenly, distances shrunk. You were able to move from one place into another and view things that otherwise you wouldn't have been able to see. And then we were given access to automobiles, and people started using them to visit yet more places, so their horizons opened. We saw changes in the way that we do things, in all sorts of different facets of our society. In the 20th century, we saw television, and that shrunk distances even more, because now we were able to see places from all over the world. We could find out news that otherwise we wouldn't have access to. And this trend has continued with the onset of personal computers now in our homes, and more recently with mobile phones, and you are all holding at least one mobile phone with you today. And where we're heading is, I think, somewhere around here, where our capabilities are augmented by machines, by processors, so they may help us in our decision making. If we have a disability, we may have a prosthetic arm, a limb that can help us move around. And we've already started seeing these technologies being embedded in our society and affecting us as individuals as well as overall as society. And this, we have seen some unprecedented changes that perhaps we consciously don't think about them as being unprecedented, but yet they are. And just to illustrate the point, look at this photo which was taken back in 2005. This is St. Peter's Square, just before the announcement of the new Pope. And you can see there's just one mobile phone right at the bottom of the screen. So look what is happening in 2013 now. Everyone is holding a mobile phone or a tablet or some other kind of device. And you may think, okay, it's a mobile phone. And yet this illustrates the point that we are now seeing a lot more data becoming available, and we are all not just consumers of data, but producers of data as well. When you are tweeting, we've heard a lot about social media today, you're creating data. When you're posting on Facebook, you're creating data. Some of this data is unstructured and poses different challenges, but we are all creating and consuming data. So I just want to make a distinction between data, information, and knowledge here, because a lot of people, there's a lot of excitement about things like big data as buzz terminology and now artificial intelligence. So it's useful to try and make some distinctions. So when we talk about data, from a computer science point of view at least, we understand this as being facts, as being structured records of transactions. So you go to your bank, you withdraw money, that's a record of a transaction that you have undertaken. Information is something slightly different because you process the data and you have some meaning. So information has meaning and shape. Knowledge, however, is something beyond information. So we are talking about here trying to understand what is happening behind the scenes. And the example that I give here is, for instance, think of the stock market. You have transactions like buy quotes and ask quotes. Then you have information. You try and analyze the data and try to extract some patterns. Knowledge will give you something different. Knowledge will give you what is happening behind. Why is it that you're seeing these patterns? So just because people tell you they have data or big data doesn't mean that they have knowledge. To get to knowledge, it takes an awful lot of steps. And we have to be careful about the claims that we make. So what's the difference? You will also have heard the terminology of data science, big data, data science, artificial intelligence. All of these are linked. So data science is this new area that is emerging, which is very much interdisciplinary. It's all about the data, structured, unstructured. We're talking about applying quantitative methods to try and understand the data that we have. But it's not just statistics, it's not just computer science, there's a lot of domain expertise. We're also talking about the kind of legal frameworks that we need, the ethical frameworks that we need around processing data and extracting knowledge and how we use this knowledge and for what purpose. So it's very much multidisciplinary. Then we have analytics, and analytics basically as a term describes the application of any kind of quantitative method that you can think of. So the application of statistics methods comes under analytics, but also the application of advanced machine learning algorithms comes under analytics too. And then we have big data, and big data is when you have truly a lot of data. We're not talking about the data that you can process in an Excel spreadsheet, or you can use a small cluster to process. Big data describes this proliferation of data that is coming from all the embedded processors that we have, our mobile phones. That's why you see this funnel there, funneling all of these data in. So basically, big data poses challenges because the traditional methods that we have, typically we cannot apply. So we need to make progress by developing new methods for storing such data and processing it. And big data are typically characterized by a number of V's. We have volume, so we're talking about a lot of data. We have velocity, the speed with which the data is arriving, like for instance in social media or in a stock market where you may have thousands of transactions taking place. And variety, which means different types of data. So imagine getting social media data alongside stock market data and trying to perform an analysis together. And these V's introduce complexity. So that's why big data is different as terminology, simply because we cannot apply traditional tools that we have. But the biggest V of all is that of value. So there's no point in having data unless you are able to do something with it, extract some useful insights that then can lead you into action, changing your behavior, changing your strategy. So typically, of course, you need to make sure that you capture the right data. Just capturing data, you may not be capturing the data that you need as an organization. Then you need to perform an analysis, and modeling is when you take it a step further and you do more complex manipulation of the data that you have, and I'll tell you a bit more about this in a minute. So we're talking about different steps that you need to follow as an organization to make sure that you do the most, you extract the most out of the data that you have. And the first and very crucial step is to make sure that you are capturing the right data that you need. So we have different levels of analytics. And again, I'm going to try and dispel some of the confusion around the terminology that you may be hearing. So depending on the kind of techniques that you are using, you draw different value. The higher the value, the more complex, the more difficult the technique that you usually have to use. So the first step is descriptive analytics. Typically here we have historical data, and we try and see what happened in the past. The next level, when we start asking why something happened in the past, takes you into diagnostic analytic, because you have a better understanding. You're not just looking at the history, but you are trying to understand what happened. With the next level then being predictive analytics, because you want to make sure that you want to use the lessons of the past to try and predict, and prediction is an interesting word that we use. We cannot offer prediction with 100% certainty. Anyone who tells you that, I'm afraid they have got their models wrong. So here you ask what may happen. And the next level, and especially for me as a researcher and others, is prescriptive analytics. So here we're trying to understand not just what happens or what may happen in the future, but actually how is it that we can influence behavior. So in the social media, for instance, domain, how is it that we can change how people behave? And you start from information and you're heading to optimization, and the further up the chain you are, the more difficult the method that you're applying. So these kind of prescriptive or predictive analytics models, they're really difficult to come up with and then apply, and obviously they're not going to give you 100% certainty. So we have hindsight, insight, and then foresight as the three levels. So just a quick setup of the work that we do, at least in the university that I work for. We usually go from data to extract some patterns, and we are now in descriptive analytics, and when we try to understand why something has happened, we're then entering the diagnostic analytics area, and here is where, as scientists, we are basically formulating hypotheses and theories. And we can use some really powerful models here as the next step, which are based on artificial intelligence techniques called multi-agent systems. So you can model even complex societies, you can model electronic markets, you can model all sorts of environments where you have different actors that interact with each other, and you can change the rules of the game and you can see what happens. So you're now into the area of predictive and prescriptive analytics. And some of these models that we use are really powerful. So we can ascribe these models and these entities that we model with characteristics even like beliefs and desires, and they are able to tell lies and manipulate within an artificial society that we create. So they can give us useful insights about social phenomena that we observe in reality and what might happen if we change the rules. And if you're able to do that, then this is quite powerful because it gives you more confidence in the kind of decisions that you are making or the strategy that you are trying to put in place. So we talked about social media a lot today and how information spreads. So the kind of models that I have just described can be used to model societies and the way information spreads in Twitter or in other social media. And there's a very basic principle behind all of this, social networks. That's the principle of homophily. So we like to associate ourselves with people like us. So our friends have very similar characteristics to us. They have the same hobbies, they share the same beliefs. And it's interesting when you run experiments in these artificial models where actually, you can see this happening, and I'm just going to show you a simulation where we have created an artificial environment, and we have inserted these artificial entities in with different characteristics, and we observed whether they would be able to find each other and stick with each other. So what you observe here is different entities. Imagine them as nodes, as we heard before. The different colors indicate different characteristics, different beliefs, and then they start exchanging information and observe how they create clusters, and they tend to stick to each other. So you will see in a few seconds that the blues manage to get together with the blues, and no matter what the configuration of the network, i.e. in the social network, then we end up having similar kind of patterns. So people will always try and get together with similar people. And this is quite powerful because it's used in all sorts of applications, not just social media, but recommendation systems like Amazon and Netflix. So no matter how long I let this run, it will always give me a similar kind of result. Now, social media generates a lot of unstructured data, and this is actually quite a phenomenon that we've got. We have been used to structured data as out of transactions, and we know their format, and we can manipulate and we can analyze such data. But the rate with which unstructured data is being created is increasing. And you can see in this graph how much unstructured data we have versus structured data. So this is quite an interesting trend. And such unstructured data contain really useful information if you have good methods to analyze them. So here's an example of analyzing basically reviews of primary care from a national health system. This is the NHS in the UK. And what we've done is we've taken, my colleagues have taken the reviews and they have clustered them. And the blue comments are the positive ones and the red ones are the negative ones. But you can now use this information with socioeconomic data to see, for instance, in which area of the UK people have the most complaints, or where is it that you have a lack of services. We leave a digital trail behind us, and people don't realize, we all don't realize how much we leave behind. There's a vacuum cleaner approach by some companies in collecting as much data as they can. Legislation like GDPR in Europe will help alleviate some of these problems, but there's quite a lot that we leave behind, and some of that is explicit information that we leave behind in websites, but other information may be implicitly gathered by the way we behave through social media, for instance, or via transactions. We have a lot of problems in this area, and Daniel will elaborate on some of these, or he will touch on some of these. I hope I have explained and you have a clearer understanding of what big data is. Basically, a lot of the progress that we have made in the last few years is because of this availability of data, but also the availability of computational resources which enable us to make progress in machine learning techniques. So this is artificial intelligence being applied on data. And machine learning basically enables you to mine a lot of data and come up with conclusions, and there's a basic principle behind it. You have a system which interacts with the environment, gets data, and then somehow it has a mind, it has this machine learning algorithm that understands the data, processes it, and then makes a decision. And some of these algorithms that we are using, they are almost like black boxes in the sense that they are powerful, they come up with fantastic results in some domains of application, but we don't yet understand how they work fully. Just to give you a very silly example, there are algorithms that are biased. If you give them examples of people, as in women, blonde women being stupid, then they will recognize only blonde women as being stupid. So we have to be careful with the kind of data that we feed in such algorithms. So this is a slide that just illustrates the difficulty in explaining some of these algorithms that we are using. So when people talk to you about big data, you need to question how much they understand the big data that they have, that the analytics techniques that they're using behind their big data. And I'm gonna stop here and thank you for your attention.